So I've gone ahead and deleted everything out, and the first thing we'll do is we'll start by bringing some numbers in and labeling those. So this first one will be renamed as the degrees. The idea here is we're using a sine wave generator, and so we need an input that corresponds to that, so we get the sine of a degree function. So I'll go ahead and duplicate this now, and we're going to create some kind of an incrementing. We don't want to do it every degree, but we do want to get a refinement of that curved surface. So copy and paste, and we'll call this increment. And then we'll look for a control called range, which takes the start and end and then steps us through things. So we'll start with an end of 360 degrees because there's no more value of 360, and we'll go at an increment of 20 degrees. We'll plug those together, a start and a step, and we'll look at a list, or excuse me, a watch list. And we'll plug that sequence in so you can see right away. So now we have a list of 19 elements starting from 0 and going up to 360. Let me zoom in on that a little bit so you can see that better. So we have now our full range of 19 sequences. And I'll leave that there, but we'll continue to build on this now. Okay, so the first thing we can do, so we start to actually see something, is to hook it to a math function. Let's see how quickly I can find this. Math sine. So we'll go ahead and we'll feed that angle in. And we'll take a look at what comes out of it. And now comes a function varying between a positive and a negative value as the sine function goes of that sequence. And now let's use this to actually create, we'll use those points that are coming out as numbers, and we'll go ahead and we'll fill in points by coordinate. And we'll quickly get a visualization here. We'll feed that into the, I think the Y, we want it to move in that direction. And you can see a little something going on here, I think. Whoops. And I think I want to feed that into, not the Y, but I believe I want to feed it into, well, I have it fed in the other one into Y. Okay, because that's correct. So I'm a little I've confused myself. But what we're really actually witnessing right now is a change in the amplitude. So we're going, if you imagine this curve brought out along this line, we're looking from the high point to the low point of those. Okay, so now what we need to do is, so we have one point, but it's not moving along the axis. So we actually need to create another range. So we'll copy this range over. And in this case, I have to introduce the idea of the length of that line, and we're going to call that the face width. So I'm just going to take a slider, and we'll right away call this face width. And we'll let that move, whoops, we'll let that move between 1 and 100, but we'll go in increments of a foot. All right, so we're gonna plug that in as the start, and we're gonna move in steps of 1 foot. So I'm gonna have to create another increment. So I'm gonna just copy this code block or number block. We'll go ahead and rename that. And the important thing with renaming is just so we can keep track of what our inputs are after we've left the project and come back to it. And this value will just be 1. And now coming out of this sequence, if we plug it into the watch box, well, we're getting 2 numbers right now, but as you'll notice when I slide this up, we'll get as many as the length of the wall is. And if we feed this right into this coordinate, now we get our sine wave generated. So we had our if I disconnect this again, all the points of amplitude are in the y-axis. And now in order to see them played out as a curve, we need to move those in time or in linear distance. So we feed that into the x and we get our sine wave displayed. And now we want to create that into a usable shape. So we're going to use a NURBS by control points. And we'll feed that into it. And now we have a line. We can get rid of these points. We no longer need to really see them any longer. And now as we adjust the width, we will see the line. We should see the line change in length. And I'm not quite understanding what's going on here. That line should be getting longer as we stretch out with more points here. Let me see what's missing in this whole thing. I have 82 points here. Oh, of course, I know what's wrong. We're not actually extending the length of our list. We need more data points. We only have the data points that we created in the first cycle through. So we need to take and make a list, a longer list of this other element. So let's make a little bit of room here. And we're going to look at the idea of introducing a list cycle. So we can continually go through that first 19 numbers. So we'll feed this list, this sequence list, into the list cycle. And just to give you a quick indication of how that works, if we take this number also, this 20, it'll go through that 20 times. And so we'll end up with a larger run of that list. So if I feed that into here, now that line can feed out over a much longer distance. But we really want this amount to be controlled a different way. We want to know the length of our list, how many units we have here. In this case, it's 101. And we want to make that the amount that we cycle this list in. And this list is always going to be 19 elements. So we just need to do a little bit of math. So we use a code block. And we'll type in, we'll make something called list length divided by 19, which is the length of that list. And our list length can be taken from, we get a number of points, but we don't know how long it is, but there is a specific node called list length. That counts the number of elements in the list. So let's go ahead and plug this into here, and then let me pull this out. Let me pull the watch box out of this and put this count in here, and we'll get a number. And that number is 101 right now. It's always 0 to 100, so that's why we have 101. I'm sorry, I'm not zooming in quite well enough there for you, so you can see that on the screen. So, all right, so we have our face, just to review, we have our face width. We're stepping at a foot to create a sequence of numbers that is our x-axis. Our math is done by going through 360 degrees and 20-degree increments to create a range of 19 units, excuse me. And we're using that list, cycling through it a few times, which we're going to do some more of that, to come up with our sine wave that feeds into this, that moves those points up and down according to the sine function at a given angle. So let's take that count now, which is the list count, and we'll feed that into list length, and that gives us enough information now. This 5.3 is the amount of cycles that it needs to make through to cover 19 divided by 101. So we'll feed that in, and we'll step back a little bit, and we'll look at what we're doing now. So as we change the length of this list, our sine wave keeps moving out according to the length of our facade. So now we have a way to make a sine wave that could be extended up or down to create our wall surface, which is where we're going with this. But our next step in the next clip will be to, I'll go ahead and clean this up a little bit, and we'll look at adding a decay to this so we can control both the amplitude and then start from 0 and start to up the amplitude as we move along it to create a visual richness to our curve.